Welcome to our last video in the series looking at the MX280005A vector signal analysis software from Anritsu. In this video we'll be looking at the Analyze feature. So to begin with, I've downloaded some data. If you go to our help menu, we looked at this before, you can download some example sets, and the modulation analysis will provide 3 different sets of data that we can play with to kind of get a feel for how this works. And I've already loaded one, which is 64 QAM. So that's loaded, and then the thing to do then is we need to set up the modulation parameters. And here it's important to realize you have to know something about the signal you're demodulating. If you just have a signal and you know absolutely nothing about it, then you're not going to get very far. And so to make it easier on the example sets, we have provided a short document, if I can pull it up here, that just in brief summary shows us the parameters that we need to set in order to, it's not the full list of parameters that you can set, but there's a few that you need to set just right in order to get some results back. And then there's a large group of parameters you can use to fine-tune your results. So we're going to do the 64 QAM, and this file is in the, so when you download the examples and it's in an archive, you unzip it, then you'll see analysis.html, and so it'll give you the information you need for these. Like I say, typically you won't be using example files, so you'll need to know something, at least the modulation type and the symbol rate, in order to get results. So we're going to just follow this. It's non-formatted, 64 QAM. Symbol rate is 4 kilosamples per second, and the measurement interval is 200. So we'll follow. Let's follow through that. So first thing is the non-formatted. So it's either frame formatted or non-formatted. Frame formatted means that we can pull out a little bit extra information. Modulation is going to be 64 QAM, and it was 4 kilosamples per second. The filters were in that list, but the defaults are fine in this case. 200 is what that was set for, so we can analyze. And it'll pop up with numerical results. So this is really the important information you get: transmit power, filtered power, frequency error, EVM, and a number of parameters. The list of parameters will vary somewhat with the different modulation types, as will the other views you can have. So we've got this. We can go to our view mode and turn on some other things. So here's a constellation diagram. Certainly looks like a 64 QAM signal. We can and so there's a number of views we can look at. With many of these views, you have some options. So here the EVM is quite low, and so I sort of change the vertical scale. I can look at interpolated constellation diagram here, or turn off those lines. A lot of the different view modes will have some options. If there's one that you want to so I have 4 here, and it's kind of small, so I can just display that one only and see what it looks like. And then turn some more on. So the symbol table is normally in hexadecimal, but that's again as an option. I can look at that in binary or hex, depending on what you want. So those are some of the common things we might want to look at. Once we've done that, one of the things you might want to do is to print that result into a report. I choose print. I'm just going to print to PDF, and I'll just name that 64 QAM. Not sure why that had an error. Hold on. So that failed to generate the report, I think because I already had it open in another, because I'd gone through this in practice. So let's try it again. I've got it closed now. So I'll save this. 64 QAM. Replace the one that was there, and then let's see if I can find it. Here it is. So we have a little report, gives us file information, the analysis result, numerical results, and then whatever views we had open will be printed onto the page. So that's how we would generate that report. I'd like to just quickly go through another example. So we'll load a different file. I was looking at one earlier. 32 APSK is one we can do. That's another one of our example file sets. So again, we go back. We need to change some of the details. 32 APSK. I'll just open up this file. We need symbol rate of 500 kilosamples per second and measurement interval of 512. So 500 here. We can set this to 512. And that measurement interval is the number of symbols. And if you put a number that's too large and there's not enough symbols, then it can't process it right. If you put in a number that's too small, then you still get reasonable results. So here we have our numerical results. And again, we can look at different. So the views here might be slightly different. Each modulation type has its own sort of things that you can do. But basically, that's sort of the common things. This one we might want to look at a little bit differently. Change that. But and again, there are various options for these views. So that is the way that we would go about loading data, setting up parameters. And again, I've got a handy little sheet because I know what these are. But you have to know information to be able to do that. The thing that we'd like to look at next is a more common practice perhaps, which is capture and analysis. So I'm going to capture a signal. I've got a spectrum analyzer with a signal generator connected to it right now, and I'm just going to capture 20 milliseconds of data and load that in for analysis. I know that the signal generator is putting out a 16 QAM pattern, so I've loaded that. I need to go to my modulation and set that to 16. I can look at my signal generator, and that is 5 million samples per second. Maybe 400. And we can analyze that. And this looks like it's a little bit messier. The signal isn't as clean as the other one. The EVM is higher, and you can see the numeric results here, power and so on. So simple way to do a capture and an analysis. I can initiate that. Now that I've got the capture set up how I want and the analysis set up, I can just initiate from here a capture and analysis, and you see this changed a little bit. And in fact, I can just put it in a continuous mode. We'll capture some data and immediately do the analysis and just do that in a cycle. So I can just kind of monitor that signal in real time if that's something that's of interest. And that'll go on until I press escape to cancel that. So that's a good overview of how we do our analysis. Involves capturing or getting a set of IQ data, knowing something about the modulation, at least the modulation type and symbol rate. And then a lot of times the defaults will get you something, and then it just takes, and our user's guide goes through all of the parameters and how to set them. There are a lot of different things that you can set up to kind of tweak the output, but that's a good overview. Thank you.